Shri Gurubhyo Namaha. Very good morning, my dear children. In the previous session, I have explained about standard potential and its calculation. Then I have given an introduction of Nernst Equation. I am sure, my dear children, you must have understood all the points and prepare notes on the topic. Try to solve many numericals on that, which will be important for your examination point of view. So, for today's session, let me continue Nernst equation along with few important numerical and relationship between equilibrium constant and Gibbs free energy. Children, listen carefully and note it down simultaneously. We have studied calculation of electrode potential can be by two methods. One is standard condition and another one is non-standard condition. I hope you remember, if it is a standard condition, temperature should be 298 Kelvin, pressure should be 1 atmosphere and concentration should be maintained as 1 molar solution. If it is a non-standard solution, all the condition may not be applicable or any one or two condition may not be applicable for the non-standard condition. Now, we will talk about how to calculate potential for the non-standard electrode. Okay. Remember, for the galvanic cell, we know that it is a spontaneous reaction and work done by the cell. Okay. When you say work done by the cell, it will be a spontaneous reaction. So, work will be done by the system. So, energy of the system will be reduces. Now, W is equal to Q into V. Here, V is developed current and Q is charge flow. Okay. To talk about charge created, we should remember the reaction takes place in the cell. I want you to recollect all the topic whatever we have discussed either in galvanic cell and Daniell cell. Now, in Daniell cell, zinc converted into Zn2 plus 2 electron will be released. Okay. This reaction occurs at anode. Okay. Now, we know that oxidation reaction. Now, on the other cell, in cathode, Cu2 plus will be gaining those 2 electron and converted into Cu. This reaction will carry over under cathode. So, under stoichiometric reaction, 1 mole of Cu2 plus gain 2 moles of electron and produces 1 mole of copper. Once again, let me repeat, 1 mole of Cu2 plus gain 2 moles of electrons and produces 1 mole of copper. Okay. Remember, change or charge on 1 mole of electron is how much? 96500 coulomb. So, 2 mole will be 2 into 96500 coulomb. Okay. Suppose if it is n mole electron, the general way of return will be, as you see in the slide, it will be changed into 96500 C into n. So, overall equation we can write as NF is equal to Q. Okay. Here V is equal to voltage of the cell, E cell. Work done by the system. So, what will happen for the energy? Energy will be reduced. So, minus value will occur. When we substitute this, W is equal to minus delta G. Okay. So, change in free energy will become negative when work done by the system. Again, I am repeating. So, change in free energy will become negative when work done by the system. Okay. When you substitute this one in the formula, W is equal to minus delta G. Already we have studied delta G is equal to NF into E cell. Okay. Now, minus delta G is equal to NF E cell. Bring the negative sign on the other side. So, delta G will become minus NF E cell. Okay. So, it is under, if it is under the standard condition. Now, the first equation whatever I have explained for the non-standard condition. In case if you talk about under the standard condition, the equation will change into delta G naught is equal to minus NF E naught cell. Okay. So, we know that already we have studied E naught cell is equal to E naught reduction potential at cathode minus E naught reduction potential at anode. I hope you remember this formula. Okay. So, here delta G is equal to Gibbs free energy change in non-spontaneous condition. Note it down children, all this. Delta G is equal to Gibbs free energy change in the non-spontaneous condition. N is equal to number of moles of electron. F is equal to 1 Faraday or otherwise 96500 Coulomb. Delta G naught is equal to Gibbs free energy change in standard condition. Again, let me repeat, delta G is Gibbs free energy change in non-standard condition. Okay. Now, E cell in equation can be calculated by using Nernst equation. Okay. Gibbs free energy in non-standard condition can be derived from thermodynamic equation. In class 11, you have studied about this. So, equation 1, whatever you are seeing here, delta G is equal to delta G naught plus RT ln Q. Okay, this equation you have studied in thermodynamics class 11. Remember, go through this from the book. Now, in this equation, we will see what are all the integers. R is nothing but gas constant, value is you know about it. T is equal to temperature in Kelvin. Ln is equal to, learn is nothing but natural logarithm. It can be converted into log base 10 by multiplying with 2.303. Q is equal to reaction coefficient. Okay. So, now after knowing about all these things, we are going to do some modification. Delta G is equal to delta G naught plus RT ln Q. Okay. In this equation, we are going to substitute the delta G and delta G naught value. Already we have derived about it. Okay. When you are substituting the delta G naught and delta G value in this equation, the equation will become minus NF E cell is equal to minus NF E naught cell plus RT ln Q. Okay. So, now divide both the side by NF, that is minus NF. Now, the equation, so everywhere you will be cancelling the NF in both the side. So, the equation will become E cell is equal to E naught cell plus RT upon NF into ln Q. Now, we are going to convert this ln Q into logarithm, natural logarithm. So, how to convert this? E cell is equal to E naught cell minus RT upon NF, ln Q will convert it into log Q by multiplying it with 2.303. Okay, please remember, either you can mention Q or you can substitute as K, both are one among the same. So, at 298 Kelvin, ln will be converted into log base 10. Okay. So, children, remember, always calculation will be asked for 298 Kelvin. So, now E cell is equal to E naught cell minus, you will be substituting all the value like R and T. Okay. When you are substituting this 8.314 into 298 and convert this ln into logarithm, so that you will be multiplying it with 2.303. So, divided by Faraday value, what is that? 96500. So, log Q. Okay. So, when you are multiplying all this value, we are going to get the value as I have shown in the right hand side. It will become E cell is equal to E naught cell minus 0.059 upon N log Q base 10. So, in the above equation, N is equal to number of moles of electron participating in the reaction. For example, zinc converted into Zn2 plus 2 electron donated. So, number of electron involved for this process will be 2. By this time, you must have understood this. So, this is called Nernst equation. Application of this is for any half cell, or for full cell we can use this equation under non-standard condition. Now, the conclusion of this is we can compare all the three terminology: delta G naught, standard Gibbs free energy, K that is coefficient, and standard electrode potential. As you see the tabular column, if delta G naught gives free energy, if it is negative, E naught's value will be positive and this will be spontaneous. If delta G naught is 0, then K value will be 1. So that E naught cell will also be 0, and this is at equilibrium condition. Okay. The last one is, if delta G naught, if it is a positive value, we know that delta E naught cell will be negative and it will be a non-spontaneous reaction, and reaction is spontaneous in the reverse direction. Please remember. Now, let me solve some numericals. Simple to solve numerical based on Nernst equation, but it is considered to be very important. Okay, the first one, calculate the potential for the Cu2 plus converted into Cu plus electrode at 25 degrees Celsius when the concentration of Cu plus ion is 3 times that of Cu2 plus ion. Please understand, always the numericals whatever we will be getting will be in 25 degrees Celsius. Please remember. Second point, for this numerical they have given the concentration of Cu plus ion is 3 times that of Cu2 plus. This is a keyword. Okay. Now, complete the reaction. So, Cu2 plus gaining those electrons to give Cu plus. So, now we know to calculate Q or K value, that is coefficient value, product concentration of product divided by concentration of reactant. This is how you will remember. So, now Cu3 plus will be plus 3 divided by 1. So, Q value is 3. Now, we will be substituting the Q value or K value in the main equation, Nernst equation. Please remember, value will be given. So, no need to memorize this. So, E is equal to E cell minus 0.0592 divided by 1. 1 is number of electron involved for this process. Okay. So, here Cu2 plus gaining 1 electron to convert into Cu plus. So, number of electron involved for this N is equal to 1. So, you will be substituting the value along with log 3. So, now when you substitute log 3 value and multiply with the other value, we will be getting 0.0282. So, E is equal to 0.125 volt. That is all, very simple. The second one is calculate the cell potential for the following. Now, you could see the reaction, iron react with Cu2 plus in aqueous medium to give Fe2 plus in aqueous medium plus Cu in solid form. When concentration of Cu2 plus is equal to 0.3 molar and concentration of Cu2 plus is 0.3 molar and Fe2 plus is equal to 0.1 molar and the given E naught cell value is plus 0.73 volt. Now, note it down the equation. E is equal to E naught cell minus 0.0591 upon N log of product divided by reactant, concentration of product divided by concentration of reactant. Okay. Here concentration, under the concentration of product we are going to consider only ions, because the concentration of product like Fe or Cu will be considered as 1 mole. Please remember, if it is in the solid form, the molarity will be considered as 1 mole. So, no need to include that in the formula. So, when you are substituting the product divided by reactant, what is there in the product side? Fe2 plus divided by concentration of Cu2 plus. Substitute the value 0.1 for Fe2 plus and Cu2 plus will be 0.3. So, when we are substituting and doing the calculation, we will be getting E cell is equal to 0.80 volt. Next one is calculate the reduction potential for the hydrogen electrode, in which the concentration of H plus is 1 into 10 power minus 3 molar and the H2 pressure is 0.50 atmosphere. So, note it down here, the pressure of the gas is given. Okay. Now, the first step is you will be writing the reaction, complete half cell reaction. 2H plus will be gaining 2 electron to give H2. Please remember, N will be 2 here. So, calculate K or Q value by substituting 0.50 divided by concentration of H plus. Here concentration of H plus is 2 numbers. So, it will be concentration of H plus per square is equal to 5 into 10 power 5. Now, substituting this value in the main equation, we know that for the hydrogen electrode, E cell value will be 0. So, E is equal to minus 0.0592 divided by 2 log 5 into 10 power 5. Okay. By calculating, I hope you remember how to calculate logarithm. So, end of this you will be getting minus 0.168 volt. The next is Sn reacts with H plus converted into Sn2 plus plus H2. Here 2 N is equal to 2 means number of electron involved for this reaction will be 2. So, E cell is equal to E naught cell. As usual, you will be writing the complete reaction. So, when you are writing log product divided by reactant, please remember what is the concentration of Sn2 plus is given, it is 0.05 and the value for H plus is 0.02. Okay. Remember, E cell is equal to E naught cell of hydrogen electrode here. So, E naught cell of hydrogen will be 0. So, E naught cell of hydrogen is 0. Other calculation we can do as such in the paper. Thank you.